Okay, so for today's topic, we're going to cover about the synthesis, right? But this one is only using a graphical linkage synthesis. Basically, this is how you want to draw the four-bar mechanism. The first three chapter that you learn, everything is given to you, right? The dimension and everything. You just calculate the speed, the position, speed, and acceleration. You can use analytical method, graphical method, as well as a complex algebra. But graphical method, I don't think we cover this semester. The first example, we're going to discuss a crank rocker mechanism. So for example, you want to design a four-bar mechanism that have 45-degree rocking rotation with equal time forward and backward. So 45-degree each. What you need to do, you need to have first point, which is O4, and then you need to have a link O4 to B is any dimension. It's up to you how long you want to draw it. You can draw 5 centimeter. You can draw 3 centimeter. It's up to you. But you need to draw another one, B1 and B2. The dimension, I mean the distance from O4 to B1 should be equal to O4 to B2, and then the angle between it must be 45 degree. If you want to create let's say 60 degree, so you need to draw a 60 degree angle between it. All right, so that the first step. The next step, you need to connect between B1 and B2. All right, any line, and then this line is just a straight line, and then doesn't matter how long, it's up to you. And then you need to draw a mid point between B1 and B, and then you got a point here, and then you create a circle first. Okay, after that you have the point O2, and then you need to translate the circle, this circle, into O2. Then you can get point A1 and A2, right? So basically, your what we call it, your four-bar mechanism will be O2, O4, B1, A1, and O2. All right. So that's the first, and then when it rotates until A2, it will create another mechanism or another layout, which is O2, O4, A2, and B2, right? Just like that. So after that, you need to measure all the distance, between O2 to O4, and then the distance from either B1 and O4 or B2 to O4, because B1 and B1 to O4, it should be equal to B2 to O4, right? And then A1 to B1 should be equal to B2 to A2. All right, so that's the dimension. And then you need to check with using a Grashof condition. So if this question in your exam, you need to create the Grashof condition as well. You don't leave your answer until here, right? If you leave your answer until here, you cannot get a full mark. Okay, any question with the rocker output with the two position of angular displacement?
So how do you get the O2 yet?
Pardon?
The O2. How
O2
do we get?
also, it doesn't matter. It's up to you where the O2 is, but as long
Oh,
as
okay.
it should be along this line, along this line, can be anywhere. You can create O2 here. It's okay.
Oh,
But later on, you need to check with the Grashof condition, right?
alright.
Right, so the next example is rocker output, two position with complex displacement. This one is when you have C1, D1 position. Okay, let's say you got two position you want to. Okay, let's say this the first what we call it, the first position that you want to create, and then this is another position, but the dimension, I mean the distance from C2 to D2 should be equal to C1 to D1, right? And then how you create it, you need to connect C1 and C2 as well as D1 and D2, and then you need to take a middle line, both of them, C1 and C2, the middle line. You need to create a middle line, and then D1 and D2 a middle line, and then the intersection there will be your first ground, which is O4. And then this one doesn't matter. You can connect this one from O4 to C, or from O4 to D, doesn't matter. All right. So, but in this example, is connect to C. Okay, just leave as it is. And then the next one, you just draw a curve. The distance for O4 to B curve is up to you. You can draw a very short or a very long, but as please do not exceed the C. Do not draw here, right? Better you draw below the C line, right? Below the C line, between C and O, then you can draw a B. This what we call the dimension doesn't matter, all right, as long as you draw the curve. And then you need to connect the curve B1 and B2 together to create a straight line. And then from here, it just similar as the example before, right, where you need to have a point O2, and then this circle this circle is drawn from here to the center. But if you take the center from the center to B, also will be the same dimension, right? Because this is the midpoint, right? There's no A point here. Yeah, the A point should be somewhere here. It doesn't show in this PowerPoint. I'm not sure because this circle you need to draw here, and then from here you can have a A point here, A2 and A1 here somewhere. So the A is 1.53, and then B should be another linkage is 6.47, which is this one, and then the ground is 7.45, and then this from here to here is the 4, which is Q. And then if the glacial condition is satisfied, then this mechanism is okay. All right, this will be your mechanism. And then the next example is the quick return mechanism. You need to know how to use this three equation. Okay, so let's say you want to create a 45-degree rocker mechanism with the time ratio of 1 to 1.25. For that, you need to calculate first the time ratio, which is alpha over beta, 1 over 1.25, right? And then the alpha plus beta should be equal to 360, which is this equation, right? the second equation. The time ratio is alpha over beta, right? Alpha over beta should be 1 over, this one should be over 1 over 1.25, and then alpha plus beta 360. So you got two equation, you got two unknown, then you can calculate alpha and beta, right? What's the alpha, what's the beta? Then in this case, the alpha is 160, beta is 200. And then you need to insert into the third equation, which is delta. You need to calculate delta, which is should be equal to 180 minus alpha or 180 minus beta. In this case, it should be equal to 20 degree. So that you can start to draw. This one O4 to B1, and then O4 to B2 is similar to the first example. All right. The tricky part is for you to find the delta here, because from B1 you can draw a straight line, and then B2 you draw a straight line. Between these two straight lines, the angle should be 20 degree, which is should be equal to delta, right? Should be equal to delta. These are very difficult to find this one, but I got a trick for you, because you know the angle here 45 degree, right? When you draw a 45 degree, then you can draw a straight line. Okay, before you draw, okay, I need to go back. Okay, you draw this line, any line, just intersect between B1 and B2, just intersect, right? Then this one 45 degree. Then you need to measure this angle. You use your protector. You measure this angle. After you got this angle, then you can know this angle also similar to this angle. But of course you can measure this angle as well, right? You measure this angle. You know this angle. Okay, let's say 90 degree. Okay, then you know the angle here should be 20 degree, right? 90 plus 20 is 110, right? 110, and then the angle here should be equal to 180 degree minus the angle here minus the angle here, right? 180 minus 90 minus 20, which is should be equal to uh
70.
yeah, 70
70.
degree. So you take a protector, you measure 70 degree, then you draw a line with a 70 degree, right? So that's how you can make sure when you have an intersection here, it always equal to 20 degree. All right, it's okay.
That's it.
Yes.
For the angle, it must for 20 degree.
20 degree because from here, when you calculate here, depend on the time ratio, depend on the what we call, depend on the time ratio basically. And then you need to create alpha plus beta should be equal to 360. And then from here you calculate delta is equal to 20 degree. That's why it's always equal to 20 degree here. But delta is, let's say after you calculate this one, delta is 30 degree, then you need to calculate for 30 degree. All right. It
Okay.
depends on your time ratio basically.
Okay.
Then the rest is straightforward because you got 0.04, 02 already. Then the next step is for you to find a point A. And then the point A, uh, okay, to find point A, you need to measure the distance from O2 to B2, O2 to B1, B2, B2 to O4 is always a constant, right? So when you measure from here to here, you got 8.24 9, and then you measure from O2 to B2 5.166. So crank plus coupler, it should be equal to 8.249, and then crank plus minus no basically coupler minus crank here equal to 5.166. So from here you need to find what is crank, what is value for crank and value for coupler. You got two equation, you got two unknown, then you can you can find the crank and coupler. After you find the crank, then the value for crank you measure from O2 to here, right? And then you can draw a circle with using this radius basically. All right. So after that, then you can create the radius for using a crank. After you find that, then you got your mechanism already, right? Which is your O2 to A is 1.542. Coupler it should be 6.70408, and then the distance from here to here is your another distance which is 5.464. But you need to check this one using a Grashof condition, right? S is 1.5, L is 6.7, P, Q. Then you need to check with the Grashof condition. If it satisfied the Grashof condition, then and you good to go. But that, let's say this one is not satisfied, right? S plus L is not less than P plus Q, then you need to redo all over again, right? But normally you can get this satisfied. Okay, the last example, let's say you have three position that you want to fulfill. Okay, let's say this is first position, second position, third position. So this mechanism need to follow I mean to go through all these position, right? So how to create the 4-bar linkage for this? And then it's the same thing. You need to connect all the A's together and the B's together, and then you got a midpoint between A2 and A1, A2 and A3 another midpoint, B1 and B2 another midpoint, and then B2 and B3 another midpoint. So you got the intersection here, right? Those intersection will be your O2 and O4, right? And then yeah, that's your mechanism basically. This one could be your double crank mechanism. It could be crank rocker mechanism, right? It's depend on the criteria, Grashof condition as well. Hey, that's all for the class for today.